Hi students, under Algebra number theory, we are in Unit 2 Finite Fields and Polynomials in lecture number 10. So in this lecture, we are going to see what is greatest common divisor, which is GCD part 2. So let's have a problem. Find the GCD of x raised to the power of 4 plus x cube plus 2x square plus x plus 1 and x cube minus 1 over cube. So first, before getting on to the problem, first you should understand the question. So what are they asking you to find? They are asking you to find the GCD, that is the greatest common divisor. They have given you two polynomials. So to divide, we need two polynomials, right? So how do we start the division? First, we need to compare the two polynomials. Which polynomial has a highest degree? So the highest degree polynomial will be used as your dividend. Clear? And the lower degree polynomial should be used as your divisor. This is being explained using division algorithm. Now what do? You start dividing. What have you done for polynomial division? An ordinary polynomial division. You had divided a polynomial over another polynomial and you have found out the quotient and the remainder. The only condition was the remainder should be of a lower degree than the divisor, or else the remainder can become 0. So these are the two things you have kept in mind for doing your polynomial division. The same thing will be done here too. But the division will not stop as such. Now what will I do for GCD? So when I will start my division as always. So when my first remainder comes, I will check whether the power of the remainder is less than the power of the or degree of your divisor. If I am going to compare it, and if I see that the remainder degree is still greater or still the same or equal to the divisor degree, then I need to continue the division unless I get the lower degree. So once I have achieved my lower degree, I will stop the process. I will stop the process, but I will not stop the problem. But I will continue another division where the remainder will become the divisor. The remainder will take up the divisor position and the original divisor will become the dividend. So there will be a big transformation happening in the second division. That is, again I am repeating, the remainder of the first division will become your divisor and the original divisor you've been using for the first division will be called as the dividend hereafter. Now again I am going to divide the dividend over the original remainder. There I will be getting the quotient and again I will be getting a new remainder. So now I will be checking whether this new remainder is less than the divisor. Now if it is less than the divisor, then I will stop and then again I will continue in my third division. How to transform? The remainder will be transformed to divisor and the divisor will become the dividend. So how long should I keep on doing this process? Will there be an end? Yes, of course. When will it be? Definitely you will be landing up with the remainder as 0. So when you get a remainder as 0, you stop the entire process. Depending upon the polynomials, you might have 3 divisions or 4 divisions, etc. But minimum for a GCD, minimum I'm saying, minimum we have to face at least 2 divisions. So after dividing, so what will be my answer for the GCD? The answer for the GCD will be given as the last non-zero polynomial. So finally you will be getting an answer as 0, right? But that should not be the answer of GCD. You have to go back to the previous division and you have to see which was the last non-zero remainder. That will be called as your GCD of this two polynomials. So now let's get on to the problem. Solution. Let f of x power 4 plus x cube plus 2x square plus x plus 1 and g of x is x cube plus 1. And now I could see that the degree of g of x is less than the degree of f of x. That is, we are just comparing. As I told you, you first need to compare these two. And the most important thing is arrange the polynomial in descending order. That's very important. Arrange the polynomials in descending order so that you won't face any difficulties during your division. So we choose f of x as the dividend and g of x as your divisor and perform the long division as done for the polynomial division, as I've explained. But here we divide f of x by g of x by division algorithm successively. We just keep doing it until we get a remainder 0. So let's get on with the division. Now there are two division happening. So let's start with the first division first. The left. This is the first polynomial which has been given, x power 4 plus x cube plus 2x square plus x plus 1 divided over x cube minus 1. And if I'm going to divide it, take this x power 4 divided by x cube, so I'll be getting x. Now take x, multiply it to the divisor, you will be getting x power 4 minus x. So which implies change the sign, cancel out x power 4 and change the sign. If this is going to be minus of plus, right? So you'll be having x cube plus x here. Now again take x cube and divide it over x. Divided over x cube. So if I'm going to divide x cube over x cube, I'll be getting the answer as 1. So 1. So take 1 and multiply it to x cube minus 1. If I'm going to multiply to x cube minus 1, I'll be getting x cube minus 1. Now change the sign, cancel out this x cube. Now this minus will become plus here. So what are the terms I'm having? I'm having x, I'm having plus 1. Still these two terms are left over. Still again I'm having x plus 1. So what are the total things I'm having? Three terms I'm having, and here again two terms. I'm just adding, combining all these 2x square, right? This plus x and this x will be added together to give you 2x, and this plus 1 and this plus 1 will give you 2. And now your remainder is 2x square plus 2x plus 2. I see that the remainder degree is less than the degree of your divisor. So I will stop the process. But I will not stop the problem. I will continue. So what is the transformation I told you? The remainder will become the divisor. Will take up the divisor's position and the original divisor will become the dividend. Now again if I'm going to divide, so I'm going to take x cube over 2x square. So I'll be getting, what am I getting? 1 by 2x. Can I write 1 by 2x here? Is fractions allowed? It is not modulo division happening here. Is 1 by 2 allowed here? Yes, it is, because the problem clearly told you over q, rational numbers. So half is allowed. That's why we are proceeding. So I'm getting half of x. So if I'm going to, that's x by 2. Just take half of x and multiply it to 2x square plus 2x plus 2. So 2 and 2 will get cancelled and x will get cancelled. So I'll be landing up with the x cube there. And then what do I do? 1 by 2 of x, right? If I'm going to multiply, it's going to be x cube. So x cube plus 1 by 2 of x will give you x. So which is going to be x square. Then plus 1 by 2 into 2 of x will give you x. Now change the sign, cancel out x cube. Change the sign, you get minus x square minus x minus 1. Again take this minus x square and divide it over 2x square. You will be getting minus 1 by 2. So you get minus 1 by 2, take minus 1 by 2, multiply to each and every term of that, you get exactly the same term. Just check it out. So minus 1 by 2, 2 and 2 will get cancelled, minus x square. Again 2x multiply to minus half, 2 and 2 will get cancelled, minus x. And again take plus 2 and multiply to minus 1 by 2. Minus of minus, minus 1 you will be getting. So change the sign, your entirely term is getting cancelled. So your remainder is 0. Now you can stop the problem because you have achieved your remainder as 0. Now how will I write? But what will be my answer for this particular problem? What did I tell you? The last non-zero number will be the GCD. So this is the last non-zero remainder. Are you able to understand? You should not consider this as your answer. You have to go back to the previous division and take this as your answer. Now therefore f of x, how do I write f of x? The product of the quotient into the divisor plus the remainder. First function. This was the first division, from the first division. Now what do I do? The degree of this is less than the degree of the divisor. So x minus 1 is equal to, now what will I write x minus 1? Now x minus 1 is getting transformed into the new, this is from the second division. X minus 1 is from the second division. That I will write it as the product of the quotient and the new divisor plus the remainder. So if I'm going to multiply, how did I get this? 2 common and 1 by 2 out. So everything will get cancelled. I'm getting x minus 1 of x square plus x plus 1. Therefore, the last non-zero remainder is x square plus x plus 1. Therefore, substituting in place of originally in f of x, x square plus x minus 1, substituting, taking x square plus x plus 1 as a common term. The rest of the term is x plus 1 into x minus 1 into 1 plus 1 time. So therefore the last non-zero polynomial, which is called as the GCD, is x square plus x plus 1. So hope you understood GCD, greatest common divisor. Thanks for watching. We'll continue in the next lecture.